另外这个有的专辑是有长期的。
都回来了。嗯。哦。你去吧。
多等一会儿，等一会儿，好像前面好几个。
嗯。
跟 PK，对，小天跟 PK。没问题是吧？哦，嗯，哎，原来你要更新是吧？哪个？那就
我不定我小时候再拿 U 盘，然后我就打。
不行，我们得，要不然的话，我们得把那个你的共享到那个屏幕上去，就是线上去，要不然线上看不到。
还有什么时间呢？
你要稍微晚一点，然后那个
我这个之后
你现在是用你10分钟你还弄不完吗？对对对，那你跟大伟说咱们2:10开始，我跟大建老师说一下。大金主任，
哎，
您能听见现场声音吗？
没问题。
哦，那个是这样，那个我们2:10开始。
好的，
好的，好的。
因为我已经一直在这等着了啊。
好的，好的，辛苦您，辛苦您。
没事儿，没事儿啊。
好嘞，好嘞。
那我就暂时先静音啊，我就一直在这儿呢啊。
好的，好的。因为那个现场这边的话呢，David 他会在，然后他这边会跟您这边他在现场来主持，跟您会配合的。
哦，他这会儿没在是吧？
对，他现在这会儿没在，咱们稍等他一会儿。
好的，好，嗯。
你先插这个，你把你的 P 放进去，把这个先好的，都好一下，可能是哪个？好的。做这个，哎，这个是没错的。 好，谢谢。大金老师，你上来了吧？
在呢，在。
哦，好。
我这随时可以开始啊。
好的，大金老师，那咱们就开始吧。
你先讲还是我先讲？
你来嘛。
啊，好，我开一下视频。好，各位在现场以及线上参加真菌毒素论坛的技术同道们，
At the venue and online, good afternoon. First of all, thank you very much for participating in this breakout session. I am Yang Dajing, research scientist with the Risk Surveillance Division 1 China National Center for Food Safety Risk Assessment. It is my great pleasure to work with David Zhang with Romer Labs to moderate this breakout session. Due to COVID control, a lot of us cannot be here physically at the meeting venue, and it is such a pity. Not being able to have this face-to-face communication is, of course, a pity, but nonetheless, it's a delight to be our participant of the session. Mycotoxin is a very important topic, and it has been discussed at 10 consecutive annual meetings of food safety. Mycotoxins plays a very important role in food safety. In the meantime, Romer Labs is a leading testing partner of mycotoxin, and they've given the forum great support so that we have the opportunity to meet once in a year and talk about a very important topic. The COVID situation has changed our lives as well as the way we think. Prevention and control not only apply to COVID, but also to mycotoxin in food. For this reason, our breakout session will focus on the post-pandemic time and focusing on the prevention and control of mycotoxin to truly protect food safety of the consumers. Presentations of this breakout session include growing, for example, the pre and post-harvest model for maize in terms of aflatoxin, as well as new varieties of mycotoxins, their testing and safety control on the testing future directions on mycotoxins, and the prevention and the prediction model on crops, as well as on feeds. In addition, we are going to cover quality control of testing and standard material, reference material. Our presenters are leading experts from home and abroad, including speaker like Professor Wang Songxue from Academy of National Food and Strategic Research and Mission, and Ms. Fan Xia, Deputy Director of China National Feed Quality Inspection and Testing Centers, and 2 experts from the University of Cambridge. They are specialists of modeling. And from Romer Labs headquarters, as well as Greater China, there were 3 experts talking about testing and quality control regarding mycotoxin. Our breakout session has a rich offering of content and also the cutting-edge quality. I am sure that the presentations this afternoon are going to offer you special insights into mycotoxin risks, prevention and control, testing methodologies to support manufacturers and food safety supervisors by giving them scientific support and backup. This is my brief opening for our breakout session this afternoon. David, would you like to contribute some comments? Okay, thank you very much, Mr. Yang. My name is Zhang Dawei, and I am with Romer Wuxi. I am 40 years old. I was born in 1982. I am here on behalf of Romer, which was established in the USA in 1982, and for 40 consecutive years, it has committed itself to the testing of mycotoxins with technological expertise built over the 40 years. We are hoping to introduce the cutting-edge technologies and products to our peers in China. And regarding mycotoxins, I've been working on the topic for more than a decade. As time goes by, in the past, we will focus on the 6 categories of mycotoxins, and later we started to focus on the cryptic categories, and today I'm going to cover some new types. We are going to talk about detoxification and monitoring. That involves the testing of the metabolites, which involves a lot of works and tasks. I would like to thank you very much for participating in our session today, and I give the time to Mr. Yang. Mr. Yang, you can start your presentation now. The topic of his presentation today is work on mycotoxin in the post-pandemic era. He is the research scientist and director of Risk Surveillance Division 1, China National Center for Food Safety Risk Assessment. It is a delight to have this opportunity to share with all of you. Regretfully, I won't be able to be here to talk to you face to face. As we said earlier, we are in the post-pandemic era nowadays. When it comes to work regarding mycotoxin, what are the new revelations? I would like to focus on this topic for the purpose of my presentation today. I'm going to cover 3 parts. First, requirements in the post-COVID era. And then I am going to talk about what should we focus on currently? What is the status quo of contamination? The third part is considering the status quo, what are we to do?
So it has been 3 years since the occurrence of the COVID-19. Well, we have the change, we have the development of the COVID-19, and so it is still in my mind about what is going on here. 3 years ago, we had the pandemic. It left a very deep impression in my mind. After we have known about the COVID-19, everybody seems to be very getting lost and kind of nervous. And because in front of the diseases, actually we didn't know much about this disease. And it was a kind of a new situation for us because we didn't have a sufficient understanding of the disease. And so actually in terms of the preparation, and you know that we will lack of resources, we will lack of methods, and also so there is something wrong, and actually it's like that. There was a problem, and then after the problem occurs, then we dealt with the problem. This is the kind of a situation where we were facing. So everybody looks like that we're busy with everything, and also we were lack of technologies. So back then, it was too overwhelming for us. That was the situation. So after 3 years, up to now, well, we still do not know quite much about the source of the pandemic. And we have some news. For example, the German scientists pointed out that it was a natural pandemic. Well, maybe it was related to lab, but it is only assumption. So right now, actually, we still didn't know much about the source of the COVID-19, but now we know how to deal with it. So right now we have the full preparation in terms of how to deal with the COVID-19. Well, for methods-wise, we right now have the basic methods to deal with the pandemic situation. So we can block the spreading of the pandemic and to stop the development of the pandemic into different areas. Every day we need to have the test. And because we want to have an early detection of the COVID-19 situation. And if we can have an early detection, then we can take countermeasures. So this is the current situation. So this is the era of post-COVID-19. In terms of the pandemic and also in terms of work, what are the new requirements for that? After years of work, we are thinking that, first of all, we need to understand the patterns of the pandemic and the features of the pandemic. After that, we know how to control it, how to prevent it. And then, with sufficient information and analysis, then we can propose the next steps. We will know about the countermeasures. And secondly, we also need the technologies as well as methods. We all know about COVID-19, and also we need to know how to prevent and control the pandemic. Of course, there are problems emerging all the time. In terms of mycotoxin, in terms of the technologies, actually, we have made a huge progress in technologies around the world, but we are still will have new challenges and new problems. And for the problems and in the challenges, we need to have active countermeasures against them. And then, in terms of mycotoxin, what's the current situation of mycotoxin? After years of work, I can say that in terms of the types of mycotoxins, we have an initial understanding of mycotoxin contaminations. So actually, we know the commonly seen types of mycotoxin. And so what kind of mycotoxin we have in what kind of matrices, we also have some understanding about that. But in terms of the control, right now, still not sufficient control regarding that. Every year, we invest a lot of resources and people into it, but we still didn't get a very good result because in some of the places, the control is not sufficient. And for that, there is one saying in terms of the prevention and control of mycotoxin. Actually, we kind of rely on the guard. For example, for high humidity, for the year that with a lot of rainwater, then there are many mycotoxin emerging. This is a kind of the situation that we are facing. We need to still do a lot of work to improve the controlling of the mycotoxin. In our work, we also come across some problems that also inspire us. Last year, in our work, my colleagues were responsible for a nuts project, and he found out that there are many cases of mold, and so mold is easier to be tested out in nuts. According to the current standards, there is a mold counting that is one indicator. And here we have a mold, and so it's easier to test out mold in the nuts. Around 20% of the samples actually exceeding the level. Especially for the mixed nuts, there are many problems regarding the mixed nuts, and also for the products that also includes the dried fruit, we also have a lot of problems. And so when they test out the molds, and then they will report it to the authority, and the authority also come across a similar situations during the sampling and detections of the samples. And so actually they issued a illustration, a detailed articles regarding that, and they do a kind of interpretation of the source of the molds. And so mold, we test out the mold, but we didn't know whether they are hurtful to the health of humans. Well, we do not know whether they generate a toxin or not. So we have collaborated with Romer Labs, and we contacted with them and to let them to do the experiments for us. Well, so, and we have done the common experiments, and we get a general idea of the patterns. Overall speaking, what kind of nuts will have the problems? Actually, we need to consider the features of it, but we didn't do a lot of research regarding the features. And I mentioned that we have asked David to do the experiments of the products. And for example, here we have tested out different mycotoxins, for example, the aflatoxin. And also we want to do a comparison analysis of that. And for the products that have been tested out, the mycotoxin, and also compare it with the samples and to test their toxicity. And so actually we find the samples that has a serious situation. and we do the experiment. This is only one part of the tested result. In terms of the phylum level, for example, we have a Mycotoxin. This is the red ones, and also we have the blue ones. That is a Basidio Mycota, and also we have the yellow ones. That is others phylums. And actually, it was for the ones that haven't been listed specifically. Then it is included in others. In terms of the genus level. In terms of the genus level, is kind of all over the places. For example, for the red ones, this is Aspergillus, and the blue ones is Alternaria. And also we have the yellow ones. The yellow ones are others. This is the unknown ones that haven't been listed, and we list it into the others category. And we have a further analysis of the data. For example, we analyze the data from different provinces. And for different provinces, and there is a feature, concentrated features that reflect that maybe it contains regional patterns. And for the regional patterns, for example, in different regions, they generate different toxins, and maybe that related to the environment of the local places. And in the natural environment, we know that there is natural mycotoxins in the natural environment. And so actually it shows a very clear regional patterns. In the food, for example, in the nuts, the mycotoxins in the nuts, and we find the initial patterns of them. However, we still need to do extra samplings to find the specific patterns of the nuts, and then that can offer support for the next steps to prevent and control of the mycotoxins. We need to study whether it is a weather's issue, whether it is the climate's issue, and we still lack of data. So in the future, we are going to do a lot of work to do the research. This is what we need to focus on. This is a problem that we need to solve. We can say that for nuts and for the commonly seen nuts, right now we didn't have a clear understanding of their patterns in terms of mycotoxins. And for the unknown ones, it is like blind boxes. For example, for the yellow part, what is the yellow part? Right now, we still cannot explain it. And in this regard, we have a lot of pressure in work. And also at the same time, besides nuts, in our monitoring and supervision work in recent years, we found out that the raw materials of the grains, and we found something in that is also related to the national policies. The overall situation is good. However, when we process it and make it into different products, then there will be issues. And so the issues related to the manufacturing process, or it is because of the raw materials. And right now, we still need to do a lot of work to do research on that. For example, here, this is the wheat powder, wheat flour, and you can see the exceeding of the values and the general levels. And here, this is the noodle, and retail did for the retail noodles, and then the level actually it is increasing. And then for the instant food sold in the market, it is still at different levels. And actually, the products that we get, the flavor, the color is darker, and also we will smell the flavor. And when it's made into instant food, instant noodles, For example, we can eat it when we have the hot pot, and maybe they will actually add some of the pigment into the instant noodles, and it will, for example, show the color of the grain. And also it has been fried during the processing, and that leads to the changing color. And also it is because have been processed with a high temperature, it will show a special flavor. And at the same time, for some of the low quality materials, after the processing, actually the processing procedures cover the bad flavor, bad colors of the original raw materials. And also we have found out that for some of the niche crops, such as maize, there are some problems regarding that. And also for some of the processed products, for example, for the chili oil, pepper oil, there are also we identify problems regarding that. And we also have the detection methods to deal with the situation.
In the past, the mycotoxin test or for grains, crops, fruits. Now it also applies to processed food, particularly like chili pepper oil, which is an entirely different scenario from crops. So testing for mycotoxins now is faced with vast challenges. In the post-COVID era, what are we to do? The speaker is disconnected. We need to understand what are the pressures and challenges. And the bottom line is we must safeguard food safety for the consumers. And after running the test, we need to understand the issues and problems. And in terms of methodology, we must have ready technologies and methods at hand. And we must be prepared to control and prevent such risks. Now, compared with many other countries at the technological level, the status quo in China is that we closely follow the latest trend, but still we must acknowledge a gap. Later, I am going to introduce some literature and publications. So we are not yet up to international standards in terms of technologies. And we are also backwards with the information and data at hand because of the technological insufficiencies. As for the root of the problems, many remains unclear. For the common ones, we might have better understandings, but for the root cause and how to control, we still lack understanding. So compared with the cutting-edge international level, there is still a way for us to go. We must recognize the gap. Despite the hard work, there is much to do for us to catch up. For example, for this forum, we intended to invite Professor Ludi, one of the most famous experts in mycotoxin studies. And here are some of his publications. This is one on food control. It was published in 2013, in which he already reviewed his tests, which he found 320 varieties of toxic and potentially toxic fungus metabolites. And 69 varieties tested positive. In addition to the common ones, there were 52 previously unnoticed metabolites or metabolites of other forms. We deal with the DON a lot, for example, but he tested DOM, and for fumonisin, he also tested new forms. like FB6. And of the 52, 14 were the metabolites of Aspergillus, 10 for Penicillium, and 12 for Alternaria and other fungus. This is another publication of him. Where he tested the Mead samples from southern Brazil. Of 148 samples, actually all of them were infected with FB1 and FB2, contaminated. In 38 and 11 samples, they tested positive for AFB1 and AFG1. In 110 and 71 samples, ZEN and DON were tested positive. Mycotoxin mostly come from Aspergillus, Fusarium, Alternaria, Penicillium, and other microorganisms. 54.2% of the samples tested positive for Fusarin C. Fusarin C. Recently, we have been working with Director Li Fengqing. Fusarin C were believed to be a potential carcinogenic compound. In the Henan sample, they found it tested positive in the sample for esophagus cancer. Its content in the sample were comparatively low and only in specific groups or demographics. So when it comes to a national surveillance, we probably won't identify that many positive cases. The other conclusion is that the Mead samples were at least contaminated by 10 mycotoxins. Within one sample, the number of contaminations was as high as 51. Now that, well, upon reading Professor Ludi's findings, we feel more pressure. What are we to do? What are we to understand? What are the contaminations in China? And which are the crops that we should focus on? Out of maize, wheat, peanut, and mixed nuts, which is the most risky for Chinese consumers? In terms of variety, fumonisin and DON, among many other mycotoxins, which one is of top concern? What is the current contamination level and which are the highest risk varieties? These are all topics for us to explore meticulously in order to live up to the duties. So the next steps, in terms of technologies and methodology, on the one hand, we need to run predictions on toxic metabolites for the nuts, for example, that we talked about. If the moles content is beyond the national standard, which are the metabolites? Are they toxic? We can use methods such as PCR to run a prediction on the potency of the toxicity. And also, if we can identify new varieties, we need to also understand about their metabolites, particularly new ones, which we haven't identified before. Again, Professor Ludi had this publication on Journal of Chromatography A. He analyzed 1,467 substances for feed. And that involves 739 fungus metabolites, 504 agricultural chemicals, 162 veterinary drugs, 47 phytotoxins, because this is for feed. So all of this could potentially be contained in the feed. So he tested all of them. What is the revelation for us? In nature, as we know, the substances interact with each other and they strike a balance. Fungus are the source of mycotoxins. In agricultural chemicals, we don't use traditional pesticides that much, but we use fungicide. So does the antibiotics, the veterinary drugs, do they kill the fungus? These are all topics for us to consider and explore. We need to find out about the interactions among the substances in order for us to have a focused, targeted study of the mechanism in order to achieve risk control purpose. The methodology should be the foundation of such work. Over the years, on agricultural chemicals, we've done a lot of work. We studied 1,176 varieties of agricultural chemicals. And we used this non-targeted method where we covered all potentially adopted agricultural chemicals. And we had a screening strategy for the data as well as data handling strategy to make sure there was no emissions. And we have a pre-processing strategy for low agricultural chemical residue, a discriminative strategy to have both qualitative and a quantitative study. So this is up to the latest level with great feasibility. In the meantime, how do we have better surveillance for mycotoxin? We have to admit that there is still a gap. Surveillance monitoring for mycotoxin. We started with 16 varieties to more than 50. And we are soon to launch a study covering more than 100 varieties of mycotoxins. We need to continuously drive our capability. And as we do so, we've got great support from Romer Labs. The next step, how do we have specific pre-processing surveillance and also management technologies? We need basic information to underpin that. If we directly duplicate international practices, we must recognize the fact that some of the mycotoxins are not present in China. So we need to have a China-specific solution for the China-specific issues. So technological-wise, there is still a long way for us to travel. In terms of measures of control, as we said earlier, for example, for nuts, mixed nuts, there's a high content of mycetes or molds. But why are they there and what varieties are there? We must know about the specifics in order to have modern controls. So we need to continuously build our expertise to really have effective, constructive work. In the meantime, we need to leverage modern statistics. In China, we've learned about the winter weeds and spring weeds. In mid-China, mostly the production is winter wheat. And this is the high-risk region for mycotoxins. So how do we establish a contamination map in order to safeguard food safety? That is a very important task that we need to fulfill. So to sum up, in the post-COVID era, in order to have constructive work into the field of mycotoxin, we must have enough information, including mycotoxin contamination status quo in China, the level of contamination, and the main varieties. In the meantime, we must have mature technologies to detect mycotoxins, and technologies to assess such data, find the relevance in order to have a foundation for corresponding methods and measures. So much from me today. Thank you very much. And I hope that the COVID situation will come to an end soon. I hope that next year we're able to talk face to face. Thank you.
Thank you very much, Mr. Yang. Thank you for your sharing. And the next one, we are pleased to invite our head of R&D of Romer Labs, Luis. And Dr. Luis is the head of R&D of Romer Labs, and today he is going to share with us advantages of aggravation and application for mycotoxin testing. So next, I would like to invite Luis.
Good morning or good afternoon, rather. And first of all, thank you for the opportunity to share with you the latest technology that we have developed at Romer Labs to increase the testing capacities, especially on-site. So I think that was a really good presentation from Mr. Yang, and I thank him also for his support. And I think it's really a pressing issue that we increase testing capacity, and that's what this system is designed for. So just a couple of words about me. I joined Romer Labs a bit more than 5 years ago, and I was personally in charge of the development of the Aggravation Pro system. And I recently became the head of R&D this year, and now oversee our R&D operations globally. Okay, so starting with the AgriStrip Pro, Vortex Aggravation Pro system. I think that perhaps some of you will be familiar with our previous line of on-site analysis systems that were called Aggravation and AgriStrip. This is a very significant step forward, especially in terms of user-friendliness. So what we saw a lot with our previous system is that there were a good number of manual steps that could induce then variability in the results, and that made the user experience, let's say, very hands-on involved. So it required a lot of manual operations from the users. So when we designed this new system, that, by the way, we designed from scratch, and it wholly belongs to Romer Labs, our main goal was always to make it as easy as possible for the customers. So to make sure that customers have to do as little as possible, and that the operations they have to do will not lead to errors. Because we found that the more operations we automate and the more operations we essentially give the job to the instrument instead of to the customer, the better results we obtain in the end. So the Aggravation Pro system is, as you can see on this image, a two-part system. On one hand, there is the instrument, and on the other hand, there are the consumables. As described on the slide, there's already 5 mycotoxins that can be analyzed using this system. And we are now in the process of launching also T2, HT2 toxin strips. So aflatoxin, deoxynivalenol, fumonisin, sarenone, ochratoxin, and also T2H2 toxin. And I think going back to one point in the previous speakers, I think it is a reality that mycotoxin testing has to be tailored to the needs of the region. And I think such a system is really handy for that, because essentially you can test for whatever toxins are relevant to you. You don't need to do a whole panel. You can monitor, you can even do seasonal differences. So if you have a season that is high for aflatoxin or a season that is high for cratoxin, you can choose that. Or if there are some toxins that are not relevant to you, then you don't need to analyze for them. Like I said, the AgraVision Pro WOTEX system enables on-site analysis. So another important aspect that we took into account when developing the system is that we wanted it to be as point of need friendly as possible. So the system really only requires, apart from the kits with the strips and the reader, it only requires water and electricity. And even electricity can be provided with an external battery pack. So no matter what kind of facility you're in, no matter how little resources are available in your facility, you can always test with this system. And what is important is that not only that, regardless of the environmental conditions, so regardless of whether you are in a warehouse that is operating right now at 10 degrees centigrade, or if you are in the summer testing in a very hot location that is at 35 degrees, the results are reliable. So our system contains an internal incubator that makes sure that the tests are always run at the same temperature, regardless of environmental conditions. So you need very few resources to run this instrument, and you can run it anywhere and you will obtain reliable results. Moreover, the extraction and analysis processes have been also streamlined. So for example, a very important feature is that no matter which toxin you need to test, or even if you need to test several toxins, you only need to perform one extraction. So the extraction method is unified for all toxins, meaning that you only require one solid sample and one extract to test for all the toxins that are enabled in the system. Even more, this extraction method is water-based. So if you're in a remote location with limited resources, and for example, you cannot easily collect and dispose of organic chemical waste, it is not a problem for us. You can test using our system because you don't need any organic solvents. So,
hi, Luis.
Yeah.
Just a minute, because you know the audience cannot see your PPT move, so you should play the play model.
Sorry, I could not understand.
So actually, he's saying that we cannot see the moving of the slides. It's still stuck in the first page. So maybe you can play it.
Oh, okay. Should I maybe stop sharing and try again? Sorry.
Maybe you can try that.
Yeah. Okay. Let's see. Let's see if that works. Okay, maybe I stay in this mode. It seems like this is working now. Okay, yeah. I will not go into full screen since it seemed that was then. Okay. That doesn't work. Okay. Apologies. Yes. Okay. It is moving now?
Yes.
Okay, thank you. All right. So as I was saying, the system is designed for on-site testing. For example, testing incoming raw materials. It definitely enables you to comply with regulations and internal thresholds. And it allows you to build an entire mycotoxin risk management program. I think from the previous slides, there's not much that we need to go back to. I will jump straight into how the system works, essentially from receiving the raw materials to providing the results. There's, as I mentioned before, two parts. On one hand, there is the mycotoxin strips, and then there is the aggravation pro system. The mycotoxin strips that you can see on the image here, they contain a lot of information, and they also contain all the reagents required for the system apart from the sample itself. So in the previous system, we had to resuspend a gold conjugate that was provided to the customers in small wells. That is no longer necessary. The conjugate has now been integrated onto the strips. So once we do the extraction and we dilute the extraction, we can apply the sample to the strip, and the sample itself will resuspend the conjugate. As you can see, the strips have a barcode on them, a 2D barcode, a data matrix barcode. This barcode contains a lot of information. It contains a unique strip ID. So each test is individually labeled. It also contains information on which lot it is. So because we use different calibration curves for each lot, then you don't need to select the lot anywhere. You don't need to make sure that you are using the correct calibration, or you don't need to input any kind of information regarding that. The information is stored on the strip. So even if you're testing multiple different strips at the same time, the system will recognize what kind of strip you're testing, and it will immediately show you the correct strip selected when you enter the sample ID information. So if I go back one strip, you can use the instrument essentially as 4 independent instruments. You can insert strips in each of the positions at your own decision. You don't need to wait for one test to be completed before you start the next one. So that in the end enables customers to test much more rapidly, because they can prepare one extract, insert one strip, add the sample, let it run, and while the sample is running, they can prepare the next extract, etc., etc. As you can see, the strips are run inside these plastic cartridges that provide the liquid support. So it's the place where you pipette the liquid, and it's the place where the liquid is then taken by the strip. And they also provide a clean and easy to discard holder for the strip once it's run and for the sample. Going back to the strips themselves, as I was mentioning before, there's a data matrix code that includes all the information that the system needs to run the strip, except for the commodity selection and the sample ID that must be entered by the customer, and yeah, all the other chemicals. Going back into the system itself, as I mentioned, there are 4 different positions that can be used independently. There is an integrated incubator. The warming up time is real quick, so if you need to switch on the system, it only takes about 3 minutes to reach the desired temperature. It has a really big and user-friendly display and interface. We really tried to not use any text, so that there is no need to read lengthy descriptions or select from confusing menus with different options. Everything is based on icons, and really the amount of input required by the customers is really minimal. You can run 4 tests in parallel. You can run 4 tests at the same time. If you have one sample that you need to test for 4 toxins, you can even insert all the strips before you add the sample, and add the same sample to the 4 toxins and measure 4 toxins at the same time for a given sample. There is no need for the customers to time any of these, or to check when do I add the sample, when should I measure. All of that is automated. And so the system detects automatically the insertion of a new strip. After the customer configures the information that is required, the system then prompts the customer to add the sample. And when the sample is detected automatically, then a countdown starts, again, automatically. That then eventually triggers the measurement of the sample. So in all of that, the customer only has to insert the strip, say what is the commodity they're testing, give a sample name, then add the sample, and then they can go. It's a walk-away operation. So after the sample is added, the customer can go deal with the next sample, or go to their computer and wait for the results, whatever they need. There is also, I will go into more detail later on that, But there is also a software for your computer that comes along with the instrument, where you can collect the data and you can analyze the data. Depending on your facility and your systems, you can even very easily from that software export the data to a LIMS system. Also, the instrument can be used in combination with a barcode scanner for sample ID. So, for example, if you are, let's say, a sophisticated customer, and you have a LIMS system where you are generating sample IDs for the commodities that you are receiving, you can print out barcodes with these sample IDs, then enter the sample IDs using a barcode scanner, and then read out the same sample IDs back into the LIMS data export. So there is absolutely no human interaction with the sample ID, no chance for error. The strips then will have a unique ID. So you would have a very secure system when it comes to sample ID management, error handling, anything like that. That's why we refer to it as even a blockchain supported system, because if you want the combination of the sample ID and the strip ID is a unique identifier that then you could enter into a blockchain system to even enter your data information into a public ledger, so that it would be visible and traceable and unchangeable. When did you test which toxin with which strip with which result? Okay. Going on to the workflow itself, well, it's really quite simple. You switch on the instrument, you select the testing that you want to do. Currently, you can test for both mycotoxins and GMO. While the system is warming up, you can prepare your extract. So I think I have an image of the extraction materials. Yes, here it is. To prepare your extract, we also provide these extraction bags, or you can prepare the extraction in whatever system you prefer. If you prefer to use Falcons or other kinds of sample carriers, but we do provide these extraction bags. So you have to weigh in your sample, add water in a buffer bag. The buffer bag we also provide, and there is no need to open, weigh any kind of buffers. It is a single dose buffer bag that dissolves with the water in the sample. So you just add your sample, add your buffer bag, and then shake for a couple of minutes, then let it settle for a couple of minutes, and then collect the extract. So here you can see, you can manually shake, or again, if you want to use some kind of automated shaking method or a vortexer or satellite mixing, whatever you prefer. Then after the extract is prepared, you have to dilute it down. So there is a dilution step. The dilution buffer is different for each toxin. That's important. So you only need to do one extraction, but you must pay attention that for each strip, you dilute with the buffer that goes with it. Then there is a very short centrifugation step of 30 seconds. So no need, because this is already working after the filter bag. There is no need for a long and accurate or thorough centrifugation. It's just to make sure that any remaining solid particles are separate. And then that gives you your finished sample that then you can apply to the strip. Before inserting the strip into the system, the strip has to be inserted in one of the plastic cartridges. Then the strip inside of the cartridge is inserted in the system. Either before this step, or if you haven't done it before, at this step, you would be required to insert a QR card with the calibration information. So each lot has a different QR card. But for example, if you are testing using a lot for a period of time, you only need to scan this one time per lot. So we recommend that our customers do this before they actually start with the extraction method. But if the system recognizes a strip that has not, that we haven't provided calibration information for it yet, then the system will request at this time that you enter calibration card. After that, the user has to provide a sample ID and select the commodity, and then apply the sample. And as I mentioned before, after this step of sample addition, the system is a walk-away system, meaning at this point, there is no more user interface required, and the user can then prepare a next extract or do something else in the procedure. I'm gonna check because I jumped a couple of slides. I want to see. Okay, yes. So if we go onto the screens in the system itself, when you switch on the system, this is the first screen that you see. So here you can see the different sections of the software. This is the part for testing. This is the part where you can review previous results. If you go into the testing section, then you can select mycotoxins or GMO. If we go into testing screen, so while we are testing, this is what the screen looks like. So if you have a finished test, this is what you would see. So there's always a color code that follows the colors on the tests. Also for the buffer bottles or the strips themselves, they all have a color label to help distinguish if you are testing aflatoxin, deoxynivalenol, or whatever else. If you click the information button that you can see here, you can see all the details for a test. So the sample ID, the concentration, the commodity, etc. This software is available in Chinese as well, and the computer software used to analyze the data is also available in Chinese. So if we have operators that need to have the system in Chinese for their usage, that is not a problem. Here, as I was mentioning, you can see the operator as well. It's a bit small in this screen, but we will see it a bit bigger later. The lot information, the type of test that was done, the result, and the matrix, and also when the test was carried out. If that's of interest, for some of our clients, that's an option they like. A printer can be connected directly to the Aggravation Pro system. The printer can even be configured to automatically print out when an analysis is completed. So for example, some of our customers, they like to get immediately a printout and tape it onto the sample or even give it to the truck driver if it's a grain elevator. So that is very easily done with a point of service printer. So small USB printer that is supplied with Aggravation Pro. And also without the need of a computer, it is possible to export the data to a USB drive. So let's say if you are in a resource limited situation where you are testing in the field and you don't have a computer with you, you can export the results to a USB, and then later on you can import from the USB onto your computer. And the export is in a CSV file format. If you have a computer, you can use our proprietary Romer Labs Data Manager software, and that software looks something like this. So maybe I try to make this a bit bigger. Yes. So it's a relatively simple software. If you connect your instrument to the computer, then and open the software will automatically detect when there are new results to be imported, and it will suggest that you import the new results. If you want, you can also manually require the system to download the new results. As I said before, the system, the program is also available in Chinese. As you can see here, these are the different options and the different fields. Here you can see a collection of results. So again, you have the sample ID, lot number, what kind of test it was, what was the result, etc., etc. You can have also the strip ID. You can here organize the results based on any of these fields. So for example, if you want to organize them chronologically, or if you want to organize them by test, or if you want to organize them by operator, you can change all of that here. You can even make some of these columns or fields not visible anymore. So for example, if you only have one instrument and you're always going to have the same value here, you can make this column not visible to save space. You can reorganize. If you want to see the test first, you can move it only with your mouse. There's no need to make any modifications. As you can see here, there is a details view in this program. And this is the detail view of a particular test. So in the detail view, you can see once again all the information about the test. So what was the sample ID, concentration, when the test was conducted, etc., etc. You can also see a photograph of the strip that is important, especially when there's a doubt whether the test was run correctly, or maybe there was a problem with the strip or a problem with the sample. Having the image is always very useful, and you can even see the quantification of the image here below. And as I mentioned before, if you have a LIMS system in your facility, you can integrate the Romer Labs Data Manager program with a LIMS system. You can even create an automatic export, meaning, so in the Romer Labs Data Manager, you can select a location where a CSV or an XML file will be exported with the results. If you want, that can be automatically done every time a new result is acquired. So that if you then have a LIMS system that is connected to this file, you would have pretty much real-time LIMS data acquisition, meaning that each result that is produced on the AgriVision Pro would be almost in real time with a very short delay appearing into a LIMS data system if that is available in your facility. Of course, to enable this, you would need support from your IT system and from your LIMS provider. But I think almost every system that I know of can work on CSV or XML files, so it should be relatively straightforward. I think what was important for us is that we have customers, as I was mentioning before, with very low resource settings. So people testing in small facilities in a farm, in a barn. Some people are testing out of their cars. But we also have at the same time customers with a higher complexity level using such systems and maybe moving away from traditional analytical methods. And they want to have data security, they want to have LIMS integration, they want to have real-time data acquisition. So I think we try to cover both sides of the spectrum and everything in the middle. And as I mentioned before, for example, the system can be run with a battery pack if there's not even electricity. It can also be run out of the 12-volt socket of a car if you need to. So it's really quite portable. It's quite small. It fits into any kind of luggage. It doesn't really take up much space. But at the same time, if you are a user in a facility with technology, with LIMS, with internet, you can connect your computer to your AgriVision Pro through your LAN. So through your local area network, you can also connect it through your Wi-Fi network. You can connect it directly one-to-one PC to AgriVision Pro. So it really is up to you how you want to use the system. And just to do a quick review on what is contained so that customers know what do they receive from us. So the kit contains pretty much everything that you need to run a test except for the water. So it contains the strips, it contains the cartridges that are used to introduce the strips in the systems. It contains the extraction buffer bags, it contains the dilution buffer, it contains pipette tips, centrifuge tubes, and the filter bags. Also tube holder, and of course the calibration card for the kit in particular. And the system itself, it contains a USB drive. So in case you want to do USB export of your data instead of to a computer, you have a USB drive containing it. It contains a QC card. So if you want to check if your system is still operating correctly, you have a card. The system can be cleaned on the inside in case there's any spills of solids or liquids. And to open the small gate at the bottom of the instrument, there is an Allen key, a hex key included. Of course, the power supply, and also interesting, there is a regional adapter also for China in the packaging itself, and a dust cover in case you are in a dusty facility, like for example grain elevators or factories, farms, feed mills. Then you have a dust cover to protect the instrument. And also there is a cable required to connect the instrument to your PC if you want to use the Romer Labs Data Manager. By the way, the Romer Labs Data Manager comes free of cost for every customer that acquires AgriVision Pro. It can be downloaded from the website, or it can be provided by our sales team. And I think that is everything that I had planned to discuss today. thank you once again for the opportunity. And if there's any questions right now, I could answer them. Thank you.
Thank you, Louis. 好，感谢 Louis 的分享。
Thank you, Louis, for the sharing. Next, we will give the floor to Mr. Da Jing to introduce the next speaker. Next up, actually, we have two presenters. They're from the University of Cambridge. Richard Studd and Chris Gilligan. They are experts of modeling and epidemiology, and they are going to talk about an integrated model for pre- and post-harvest aflatoxin contamination in maize. Please.
Oh, I'll just share my slides. Okay, so we're here today to present an integrated model for pre- and post-harvest aflatoxin contamination in maize. As a little context for this talk, this work forms part of the Food Safety Coalition, which I think there have been a few sessions on already at this event. So here we are on day 2. The other sessions on day 1 have been by Dr. Guangtao Zhang and Chris Elliott, and there's another talk earlier today from Jagger Harvey and Jeffrey Morris. As a bit of background for our research group, so we're based in the UK at the University of Cambridge, and we worked on many plant pathosystems previously, both in the natural environment in the UK and worldwide. And with such a variety of pathosystems, our guiding principles are we want to make sure we're asking the right questions, delivering useful answers, and building a model that is parsimonious, so as simple as possible in order to actually get at the fundamentals of the system. So in order to motivate this project, we were provided with some data by Mars from maize contamination in one of their pet food facilities in India. And they were noticing that they had high rejection rates due to excessive aflatoxin levels. And also these rejection rates were had sort of annual trends within them. So the second half of the year was typically worse than the first half, with the aflatoxin contamination being the primary driver of rejections of shipments. They also noticed that in addition to these general patterns of higher aflatoxin in the second half of the year, they were seeing really marked variation in the level of aflatoxin, even within a single month. There could be very, very high and also very low aflatoxin levels. So the idea of this project was to kind of work out what was driving these general patterns and also the variability in aflatoxin levels. So this project was aiming to use high-resolution meteorological data to predict both Aspergillus flavus amounts in shipments, so the fungus that produces the toxin, and also the level of toxin in these shipments as well. So that the model takes things all the way through from planting to harvest and delivery in order to make the risk predictions. So the model has several components, and we'll go into more detail on all of these, but this is the general flow of the model is that in order to think about what we need to predict at the factory gate, at the point of delivery, down here, is we need to be able to work all the way from planting, have the plant growth, harvesting, and then any management that happens after harvest, the storage conditions, and then delivery and actual, we also model the sampling process, so the measurements of aflatoxin within batches. And this model unifies both the biological side for an individual shipment, so that the processes that drive aflatoxin production and fungus growth with the supply chain that determines what material is delivered and when. So, as I mentioned earlier, the region of interest for this project is India, and the catchment area we're interested in is this region around Hyderabad, so sort of southern central India. The Mars facility is near Hyderabad, and then they source from several different market catchment areas. So this is that square is the area we'll be focusing on for the rest of the presentation. So the most fundamental thing here is that if we're thinking about delivering maize shipments to the factory, we build up a geospatial history for each batch. So the batches will be planted at some point in time at some locations. So here, the red crosses on the map indicate the initial locations of some batches while they're growing. And at the point they're growing, they'll be subject to some environmental conditions. And then over time, the environmental conditions will be changing, but the batches will kind of remain fixed in their field as they continue to grow. At some point, they'll be harvested, and then they'll be shipped to a marketplace where they'll be stored, and they'll be stored there for some duration. And then at a later point, again, subject to environmental conditions, when they're in the market storage, they may produce more aflatoxin or have more fungus contamination. But then a few months later, they'll be delivered to the facility for use, and they'll be tested for aflatoxin at the point they're delivered. So the pre-harvest component of the model, we consider the biology of the Aspergillus flavus fungus. We consider the biology of the plant itself. So the plant growth is important to the plant being able to be infected by the fungus, and also for providing kind of the conditions for the fungus to grow within the plant. And then we're also combining that with high resolution meteorological data, which drives all of the biological processes within the model. So the environmental data, here's an example map of the relative humidity. We use hourly data at finely spatially resolved scales. And so that will change over time. That then drives biological processes such as the fungus growth rate, shown here the temperature response for growth rates. And also this drives the plant growth model as well, with the plant's susceptibility and the plant's internal moisture activity being driven by, again, the environmental processes. Another key part of the pre-harvest model is the supply chain. In India, they have 2 cropping seasons per year. Kharif crop, which is responsible for the majority of production, which plants from roughly June to August and harvests sometime between October and January. And the Rabi crop, which does the other 20% of production, and it plants in October, December time and harvests March to May. So in terms of sourcing, we can immediately see that you can only source kind of very fresh material for about 6 months a year, and the rest of the time, the material necessarily will have remained in storage for at least 6 months, or up to 6 months, while there are no harvests occurring. To give a brief overview of the pre-harvest model structure, the main components we're looking at here are either primary infection. So we know that the Aspergillus flavus fungus is ubiquitous in nature. It's found almost everywhere all the time. So there's a primary infection source creating new Aspergillus flavus infections in the crop over time. And so we model ambient sporulation driving fungal infections in the plant, again, subject to environmental mediation. and plant growth stage. And we also model within plant multiplication of the fungus, again, subject to the plant's internal state and ambient environmental condition. And then also the fungus is continuously producing toxin when the environmental conditions are right. Then the pre-harvest model results are fed into the harvest processing steps, where we take the final levels of fungal contamination and the toxin amounts at the time of harvest, and those are passed to the harvest processing, at which point there'll be some level of contaminants added by the harvesting process, the fines, and then we model filtering and drying and other harvesting processing steps. And then the material is put into storage with whatever remaining fungus, toxin, and contamination levels. Another feature of the Indian system, which is not necessarily applicable worldwide, is that the material is stored in jute bags, which can themselves be recycled and introduce additional contamination if they're not decontaminated from year to year between uses. This information is then fed into the post-harvest model component. And when we think about the post-harvest model component, the important things to consider here are, where is the material stored? Because if you can see on the little animation on the right is showing that there's significant daily variation in the environmental suitability. So where is the material stored? How much kind of suitable conditions is it exposed to over those storage times? How long is it stored for? So again, the supply chain. And also, is the material being stored in, say, a nice climate controlled silo, or is it just kind of positioned under a tarp somewhere? Because those will have effects on, significant effects on how conducive conditions are within storage, beyond just the pure environmental drivers. And has any intervention been done in order to keep the material clean during storage? So the post-harvest model structure, again, key part of this is the level of fungal contamination and the multiplication of the fungus within storage. Additional fungal contamination can occur if there's any contamination from, say, fines within the storage facility itself, or within the bags that the maize is stored within, and again, the toxin production. All of these processes driven by the environmental conditions within the storage facility, which could be just purely driven by the outside environment or be climate controlled. And then the material is at some point in storage, it's selected for delivery. However, when is it delivered is determined by the supply chain. So in this animation, if we think about a delivery in the month of January, potentially material could have been harvested either 1, 2, or 3 months ago. So you have a range of options for when material delivered from the latest Kharif harvest would be delivered in January. If you look at February, then obviously you've got the same thing, but potentially a month longer. When you get through to March, you could either be sourcing from some older Kharif crops, or you have the option to take some new harvests from the latest Rabi facilities. But you see that there's a range of options for when and how much time things have been in storage for. And this will vary over the course of the year. We were actually lucky enough to have access to the data telling us over time which harvests contributed to the deliveries in any given month at the Mars facility. So the first half of the year, in, for example, 2012, Mars were getting deliveries mainly from the Nizamabad region, and these would have been from the Kharif crop there. And then over the course of the year, they transitioned more towards the Guntur region down in the southeast near the coast, with introducing towards the end of the year a few shipments from Bellary, and they were sourcing from both the Kharif and the Rabi harvests. The following year, there was a marked change in sourcing patterns, and actually they were using much more material from the Nizamabad area, with a little bit from Bellary in the first couple of months of the year. Then they switched to Kharif, from Kharif to Rabi in the middle of the year, and then back to Kharif for the latter part of the year. And these sourcing practices, we reflect them in the model outputs. So when we run the model to validate, or when we make any predictive use of the model, we pay close attention to where the material is being sourced from. So in terms of validating our model, we used Bayesian methods to estimate any unknown parameters in the model. Our methodology is essentially we run the model with a set of parameters, simulating tens of thousands of different shipments of maize, and see if the model results match the data. And we look over a wide range of model parameters and do several million iterations of the model in order to make sure that our results are robust and our parameters are as good as can be. On the right here, we can see a comparison of in blue, from the model's predicted aflatoxin levels over time. So this is over a 7-year period. And in red, the data we received from Mars about their median aflatoxin levels from the shipments that they received. And so we see there's a good correspondence between the median levels, and then the model's also predicting the full distributions of monthly aflatoxin levels in deliveries. And so again, the dashed lines indicate the upper and lower quartiles of aflatoxin levels in shipments received. And we see again, there's a good correspondence between the levels we saw in the data and what the model predicts. So now that we have a model and it's been validated, we want to actually use it to answer some useful questions. And so we can perform various scenario analyses, looking at different management practices or different interventions to see what any kind of changes to the system could provide in terms of benefits. And so here, as an example, a cost-benefit analysis could be performed, thinking about weighing up, should you invest in better filtration practices to clean material after harvest versus investing in controlled environmental storage during the storage phase. So on the left, we have the filtration graph. In both graphs, the blue top line is the baseline aflatoxin levels across the years, as would be done with no interventions. And then we can look at introducing either a moderate level of filtration or a very effective filtration for these two green lines, which reduce the levels of aflatoxin at delivery, versus on the right, these green lines indicate increased levels of cooling and controlled environment in the storage facilities. And so using this, we can have a quantitative basis for weighing up the costs and benefits of different interventions and potential benefits. We also have this model, so it's mechanistic and it's driven by environmental data, which is available worldwide. So it's globally applicable. We can plug in the environmental conditions for various regions around the globe. So here we just transplanted the model to Tanzania. And if we have data, we can also introduce local practices in terms of planting, harvesting, cropping practices, and also local storage practices. And we can generate large-scale environmental suitability maps such as these. So here we have the region of Tanzania, an annual average for the country on the left, and on the right we have just an animation of the monthly suitability levels, showing the significant variations within the year and also spatially as well, for where is most suitable for aflatoxin production. So in terms of potential uses for this model, so we want to obviously make it available at a strategic level, and potential users for this, we envisage that obviously both commercial users such as Mars could be thinking about where they want to identify their sourcing and storage regions, but also there's government and kind of national and local stakeholders could be interested in thinking about food security, storage locations, and public health kind of hotspots. And so kind of thinking about policy could be informed by these quantitative measurements. There's also potential for real-time usage, because we can use this model with up-to-the-minute environmental data and also forecast environmental data going a few weeks into the future. So we can use this to think about when it might be optimal to apply interventions within farms, also thinking about timings for harvests and market kind of interventions for storage management if there's predicted kind of recent or future harmful conditions, and increased monitoring protocols during high risk times, and also maybe more kind of dynamic switching of sourcing locations based on where is predicted to be the best at any given time. This model has actually been used internally within Mars for a while now. So they have various dashboards and facilities available to their internal users that they can use to get an overview of the situation. So they're trying to predict what the current risks are and also compare this to previous years to get some context for the current conditions. So one of the ideas is to get sort of a traffic light system where you can get a quick overview to see whether your current situation is good or bad, and whether you should take any interventions at the moment. So I'd like to acknowledge a few stakeholders here. So as part of the group, we've had several contributors to this, but we've also had some great assistance from Mars, and the UK Met Office has been providing us with the meteorological data. So with that, I say thank you, and if there are any questions, happy to take questions now. Otherwise, I think I'll be at the panel session later in the afternoon.
好，谢谢 Richard 博士。
Thank you very much, Dr. Richard. You made it all sound very easy, but actually to have such a model, it takes a lot of data, a lot of computation, matching, in order to have a predictive model. So much work, so much workload involved. Thank you once again for the introduction of your model. Thank you so much. Next, We are going to have a presentation from the other moderator. He is with Romer Labs, Dr. Zhang Dawei. David, please. Thank you very much, Professor Da Jing. The topic of our session is new mycotoxins and the warning mechanism. We started by focusing on the laws and regulations, the 6 categories of mycotoxins, and then the hidden types, and then new mycotoxins. So I am going to cover the several parts, which are the new types of mycotoxins that we should focus on. Professor Lu Di had more than 200 test methods, out of which we should focus on the regional differences. Each country origin is different. We run the checks on mycotoxins in China yearly, so we know which are the new ones of interest. And then we are going to talk about the testing methodologies. Because of these mycotoxins being very new, we don't have too much ready testing methods. And then we're going to talk about the 2021 mycotoxin contamination on maize for feed. First topic. First, we're going to talk about the Merieux. So this is the structure here. They are all the metabolites of fusarium, and they are all pervasive. Most typically found in dried fruits and nuts, oil seeds, and cereals, and it is highly relevant to other metabolites of fusarium. Later, I'm going to show you data, comparisons with fumaricins. Normally, we think that there is no limit of the dosage on fumaricins. There is this plant called Cordyceps subbolifera, and several mycotoxins are found with this, and there's national regulation on the dosage. It should be lower than 3 ppm. That is quite a strict rule. We are a third-party testing lab. So many of our customers ask if we can test buviricin. Professor Han's team was the earliest to test this, and they also tested for this specific plant in question, but they cannot issue a third-party test report, so they refer the customers to us. So almost each day, there are customers approaching me for a test on this plant. So there is a regulation on the dosage or concentration less than 3 ppm. The next one is moniliformin. We know more typically the metabolite of this fungus is fusarium. So more than 10 varieties of fusarium could have such metabolites, and this is typically found on oats, soybeans, maize, and wheat. And MON has very high toxicity for animals, particularly poultry. And also our customers approached us for this. They have a large animal feed manufacturing facility. And they noticed some symptoms and suspected the contamination of MON. So the customer came to us requiring a test, and we are capable of testing multiple mycotoxins, and these tests came back positive. To the left, well, during Dajing's presentation, when it comes to risk assessment, EU is a bit ahead of China. Each year, the EU has a scientific opinion. They focus on new mycotoxins, assessment of the toxicity, and the test rate, positive rate, assessing the contamination, based on which regulations can be formulated. Laws and regulations do not come out of the blue. It's underpinned by data testing methodologies. And to the right, I look at some publications and literatures. The test rate of MON in Norway of oat and wheat, there are high positive rate, and the concentration is quite high. And also for Sweden, Italy, and US. In US, they tested 134 maize samples, and the positive rate was 50%.
So actually, another one is the Aspergillus versicolor, and actually there is the structure of it. It is similar to the Aspergillus, and for example, in the rice and the cereal grains, so we can test it out. And this is the Cancer Association of the international community actually listed as a very high mycotoxin that can lead to cancer. It has high potentials. And also, as mentioned by Dajing, and for cerium is also as the level 2B, and this one is also as the level 2B that may lead to cancer. Actually, in the growing stage, and it is quite possible to have the Aspergillus versicolors, and as well as in the stories, as well as in the growing stages. And another one is mycolic acid. Mycolic acid, it has low level of moisture, water activity, and also it has a low oxygen contention as well as a low pH level. And in terms of the storage, and it is easy to test it during the storage stage. And for mycolic acid, it can be used in the drugs. It is really tricky thing. And because we also mentioned about that, the source of the food and the source of the medicine are coming from actually the same source. And for example, if you eat something, for example, a food too much, will that influence your health? But the toxicity of mycolic acid is not very high, as mentioned by Professor Dajing, and we have do the toxicity analysis of the nuts. And actually in nuts, we have the mycolic acid, and we actually search a lot of literatures why we will have a mycolic acid. And for example, for the nuts that they have the mold, and we have the blue mold. The blue mold is easy to generate mycolic acid. And also in my PhD study, I actually studied about the feed. And sometimes we, for the feed, we have the anaerobic fermentation process. And during the anaerobic fermentation process, maybe it is also easy to generate mycolic acid. Another one, So here it is. This is one of the example from a documentation from Italy, from the chestnut. We like to eat the chestnut. And also we have the different flavors of a chestnut. And so actually you can see that it is also the testing out the ratios of mycolic acid in chestnut is also very high. For example, in the roasted chestnut, you can see that the test out ratio is increasing. And so if, for example, before the roasting, then the water activity in the chestnut is high and it's not easy to test out the mycolic acid. But when you roast it and the water is gone, then it is easy to have the mode that we have the mycolic acid. And secondly, how about the detection methods for the new type of the mycotoxin? I also searched the literatures, and we mentioned about some new types of mycotoxins. There is one that have the standard, that is for the test out of the Aspergillus vesicolor. And actually in 2018, Professor Yang actually issued out a industrial standard for the Aspergillus vesicolor and how to detect it. Otherwise, for the other ones, we didn't have a standard for it. We didn't have a detection method for it. And for recent, right now, we didn't have any detection standard, but in the future, we are going to have it. And actually, the government authority has set up a project, and it includes the biovaricin as well as the Fusarium oxyporum. And they want to set up the detection method and standards for it. You know, that is really takes a long time from the setting up of the project and to the final issuing of the standards. And it takes about 2 to 3 years. And right now it is kind of a blank in terms of the detection of the biovaricin. But for us, Roma, we can help with that. And for the MON, if you search the Chinese literature, there are not many data regarding the detection methods of MON as well as the mycolic acid. The only one we can get is from Professor Qi. Actually, he is really a pioneering. And in 2013, and for the article, he actually researched on the detection methods regarding the MON. Actually, in 2013, he already started to pay attention to the new type of mycotoxin. And for mycolic acid, we didn't get any literature regarding that. And for Wuxi Lab, we work with the Public Security Department and Professor Yuan's team. And we have isotope LC detection method. And we have done the experiments. And we put the mycolic acid in our project because based on the big data, we checked what kind of mycotoxins are easier to be identified in the food. And so then we list mycolic acid as well in our project. And lastly, I would like to share with you about the contamination situation of the new types of mycotoxins. Every year we are doing this thing. One thing is that we have the survey regarding the mycotoxins, and we have the global survey, and also we have the survey in China. Besides that, and for China regions and for wheat, we have a survey on wheat as well as maize related mycotoxins. And previously, our parent company is doing the additives in the feed, and they are quite a famous brand. And so they actually have a business regarding maize. Maize is one very important raw materials for feed. So they actually have done a survey regarding maize related mycotoxins. And last year we received around 313 of the samples. And you can see that here is planting maps of maize in China. Besides the west and south of China, actually, we have covered the major planting regions in China, except the west and south areas. And also we have the data from different provinces. In 2020 and 2021, here it is a comparison of the data. So actually, in these 2 years, I think that the contamination of a mycotoxin actually is increasing in these 2 years because we have extreme weathers. It's quite common. It's quite commonly seen, and we not only have not only need to have the fungi, and we also need to have the weather conditions for the mycotoxins. For example, in 2020, and so we actually identify the mycotoxin from 4 to 17. And then we have from 12 to 26. And so actually, we identified many of the mycotoxins. So in recent 2 years, the risk of mycotoxin, the risk of contamination is really high. So this is new types of the mycotoxins. And here it is butyric and Fusarium oxysporum, as well as MON, testing out. And we also have the average values of it in maize. We have the normal 6. We have the maxed mycotoxins from maize. We also need to focus on butyric as well as MON. And also it's quite common to identify these 2 mycotoxins in maize. And also we have the Aspergillus versicolor and mycolic acid. Also, we need to pay attention to this too as well. We have new types of mycotoxins, and we need the data to support our research. And starting from 2017, we established the WuXi's lab. We only have data of 5 years. For EU, they have done this for about more than 10 years. And so that's why they have the prediction models. We are discussing about this as well. For the prediction models, you need to have the variables. Variables is very important. Also, we need the support of the big data. So this is about the data of the butyric. We really pay high attention to that. You can see that in different regions in China, you can see that the test out ratio is 100%. And it's like the fumatoxin, fumonisin, as well as the other commonly seen mycotoxins. I think you need to really pay high attention to that. And also, especially in Shandong province, we are going to have further research on that. In Shandong province, the testing out ratio of butyric mean value is higher than the other ones. For example, here it is over 500 for the mean value. For Shandong province, we actually get a lot of samples, and you can see that the testing out ratio is mean value is very high. We also study about the relativity analysis, and you can see that the real situation has a relationship with the research. For example, for the aflatoxin as well as the Aspergillus versicolors, they have a high relationship with the research as well as the butyric. I studied on the literature, for example, FUM. There sometimes is a joint toxicity impact that will influence the food. If you want to really do a good understanding of it, and you need to do a lot of research. And maybe, for example, sometimes we have a butyric and we also have FUM mycotoxins, and they can actually have a joint toxicity that will lead to an increase of the values. And also we have the MON as well as the aflatoxin as well as the butyric. They also have kind of joint forces. In China, in our situation, and actually the fusarium contaminated the substance. Here we have iceberg. The iceberg means that we really pay high attention to the upper part of the iceberg, but for mycotoxins, there are so many unknown areas which are waiting for our exploration and research. And sometimes I talk to my mentor, and sometimes I cannot answer his questions because I think that I still lack of accumulation of the series. Well, we have talked quite a lot about the new types of mycotoxins. Actually, we have a comprehensive alarming and detection methods regarding the mycotoxins. And together with Mr. Lin, we actually established a warning method for 67 mycotoxins. For the supervision authority, they hope that they can reach 100. And internationally, actually, we set up the methods for 88 mycotoxins, and also we verify our methods in lab. And here we have aflatoxin, and we also have covered aspergillus vesicolor, and also we have the blue mold types. And for example, and we covered quite a lot of the new types of the mycotoxins, and sometimes because of the long storage time, that really leads to the blue mold generation. So actually, for the last part, I also want to use one thing, just like what I mentioned before. For Roma Labs, for 40 years, we just do one thing, that is the detection of the mycotoxins. I hope that we can do the best. And also, we want to work with different players in this industry and to enhance our communication and to promote the food safety and to make progress further. Thank you. Thank you, Da Wei.
I really learned a lot from your presentation. Despite that, well, let's say Da Wei works in a commercial lab, but he really conducts very professional studies, including established methodology, analysis of data, and coming up with warnings and precautionary conclusions. That is really insightful. So I think we should work closely together to really drive food safety in China. So thank you very much once again. Next up, we are going to hear from Wang Songxue, researcher from Academy of National Food and Strategic Research Administration, who is going to talk about research and application of grain mycotoxin risk monitoring technology system. We don't have the sound. Please bear with us for a minute. Dear experts, peers, friends, good afternoon. I would like to thank the organizer for their invitation. It's a privilege for me to participate in this breakout session on mycotoxin. I am going to talk about the research and application of grain mycotoxin risk monitoring technology system. My presentation will cover the several topics, including the food safety backgrounds and status quo, and our principles and ideas in solving the challenges, current progress, applications and demonstration projects, as well as my suggestions. As we all know, mycotoxin contamination is a global food safety challenge. It is very difficult to contain such risks or manage it. In developing countries or developed countries in Europe and America, there are mycotoxin contamination. And it is found throughout the process from planting to harvesting and storage and distribution. Most importantly, mycotoxin has severe harms to human and animals. It's carcinogenic. So most countries who are capable of doing it, they have issued laws and regulations to contain such contaminations. China is a very important agricultural country in the world, so mycotoxin contamination is a very important challenge. It has a lot to do with the meteorological conditions, on which I won't elaborate today. So how do we prevent and manage mycotoxin risks? This is a very important task for China's food safety management. Prevention and control of mycotoxin contamination. Well, it is a topic of global concern. Mycotoxin contamination is very difficult to prevent or eliminate. So governance has evolved to be risk prevention centered. This is a very important change in mindset. So throughout the entire circulation chain, we need to identify risks, evaluate risks, and reduce the risks to an acceptable level. Maximizing the utilization of crops is an important objective. With such ideas, the key challenges of mycotoxin contaminations are 4: monitoring, sampling, inspection and detection, meteorological traceability, and risk prediction and data resources. Addressing these challenges, we are demand-oriented and focus on the key challenges to develop products, formulate standards, and establish pilot projects to come at the systematic solutions. And we've made 4 progresses. 1 with monitoring and sampling. We have the monitoring technologies. And then with logistics, there is an efficient testing methodology and autonomous quality control system and traceability capacity, and also developing a data library. And these achievements enable us to better manage the risks and achieve monitoring of mycotoxin contamination. And it has comprehensively improved our capability of managing mycotoxin contamination. And next, I would like to talk about the key progresses with monitoring and sampling. There is no effective guaranteeing of the scientificness, representativeness, authenticity, and traceability of the samples. Addressing this, we established the monitoring systems, which is based on satellite remote sensing, geographic information, grid management, and the pattern of contamination, as well as IoT. We arrived at a management system that made sure of the scientificness, representativeness, authenticity, and traceability of the samples. This is our grid-based system. With a satellite remote sensing, we get a map of the plantation and density of the wheat, and different colors represent different densities. Based on the geographic information, we come at a grid map of the plantations, and based on which we can reasonably select our sampling regions to make sure of their representativeness. This is our grain mycotoxin sample management system based on IoT. It includes a backstage management system post-sampling, a mobile app, sampling information upload interface. This is based on GIS, and it generates a QR code as a label to be transmitted across the chain, which enables traceability of the samples. Based on GIS, with a backstage system, we can effectively manage and analyze our samples and trace the entire process to learn about the latest updates of the sampling. This gives us better efficiency, and based on an electric fencing system, GPS, we can make sure that within the electronic fence, which is 11 square kilometers, we can make sure of the authenticity of the sampling. For 6 consecutive years, these systems work for food testing surveillance stations and warehouses, as well as processors. The samples were taken from Henan, Hebei, Shandong, Anhui, Heilongjiang, Jilin,内蒙, Hunan, Hubei, Yunnan, altogether 16 provinces and prefectures. With testing methodologies, in the past, there was the challenge of not being able to test, and the test doesn't work, the test doesn't report accurate findings, and it takes too much time. To address these issues, we've developed new mycotoxin testing methodologies, which covers the planting bases, national, regional, provincial surveillance centers. So now it's rapid and automated. Based on immunomagnetic absorbent method, we can have an automated pre-processing methodology. This has been made into an industry standard. The EU has visited us, and we demonstrated this system. And this was spoken highly of by Professor Ludi. He thought that our method and solution is highly promising. This is the immunomagnetic beads in comparison with the immunoaffinity columns. The technology is fast, efficient, economic, flexible, so very cost-effective. In order for the new technology to be applied in more labs, we worked with Dongfu company to manufacture this commercialized apparatus and test it. It can test 10 samples in parallel, and we have launched a new device with 24 slots. This is a solution based on dilute and shoot technology. This is a new methodology to test mycotoxins in laboratories, fast, high throughput, multi-component. This method allows 16 samples to be tested simultaneously. It takes less than 1 hour, and based on isotopes, we have better accuracy of the test results. And it is recommended to have a wider application. And to address the high price of isotopes, we developed this commercial C13 stable isotope internal standard kit. This is a first of its kind test kit, and we've already transferred it to make it commercial. And there is a multi-toxin test kit. With this method, the process and workflow is highly streamlined. In the past, it took 1 hour. Multiple processes, now less than 3 minutes. Now the entire process is environmental friendly and highly efficient. We've organized 22 labs for international collaborative studies and participated in multi-international comparisons. Altogether, we submitted 104 test findings, and we contributed to the formulation of the ISO standards. With traceability and QC, there's the challenge of limited number in the samples and number of varieties. Many of the samples were imported, and we don't have an autonomous traceable industrial chain. So to address this challenge, the mycotoxin reference material development system integrating high purity solid standard, high precision solution standard, high quality natural pollution matrix standards.
So actually, we helped to achieve the high efficient and high stable of the detection of the trace impurities, and also we have established a controllable and traceable food chain. And this is for the toxic impurities verification system, and we have established 306 mycotoxin and toxic metabolites food library as well as a screening library. And actually, for once, we can analyze over 300 of mycotoxins and the metabolites that really grant great support for the verification and detection of the impurities. And so here for mycotoxin solution reference materials, and we set up the goal, and we also utilize a efficient and stable technologies, and we used multiple ways for the tracing technologies, and we built up a system that can be in mass used for in terms of the mycotoxin solution reference materials, and we have get many national level certificates regarding that. And in terms of the reference materials, and we have researched on that, and we also have set up the technologies regarding that, and as well as a stable control technology. And we researched the reference materials of a different mechanism, different toxins, and different values, and we get 15 national level reference material certificates that meets the demands of the detection needs of the lab as well as on-site. And also we propose the idea of the grain mycotoxin natural contaminants raw material reference materials preparation proposals, and actually we provide a product for the detections of the mycotoxins in the grains, and that's help also with the implementation of the good grains action plans of China. And in terms of the risk evaluation, data resource building and predictions, and we also set up as a support regarding the data. And right now we have the issue regarding the mycotoxin pollutants distribution, and the water content is not quite clear. And so we set up the data bank, the library, and we cover a full coverage that provide very good data for the limits and reference materials and as well as the making of the standards for the mycotoxins. And according to the features of the mycotoxin pollutions in China, as well as distribution levels, we have set up the models for the prediction of the risks. And here in this project, we set up the contamination data bank. It includes the contamination data, and also it includes the impact factors that actually help to improve the quality of the data as well as the coverage range. And that help with the making of the standards for mycotoxins limits, and also it can help with the alarming. And we have set up a prediction model. And so, for example, 1 month before the harvest, we can have a dynamic predictions regarding the contamination level of the mycotoxins when we harvest them. So here, this is the data bank. It includes the data, the detection data, as well as the survey information. And we also provide some of the data to the related authorities to evaluate the risks of mycotoxin of the grains, as well as some setting of the limits. And so that also helps with the work. It has become a very important part for the making of the limits of mycotoxins in grains internally and externally. And we furtherly established the demonstration technology of mycotoxin risks. And for example, here you can see this is a risk map of the contaminants, and we also have the automatic data processing software that shows the mycotoxin contamination features distribution level in grains in China. And here, and we have a project regarding the risks of the mycotoxin contaminations of the grains, and also we accumulated the data along the Shanghai River, the sea, about the harvest of the wheat, and also we collect the data regarding the DON. And based on the data collected as well as the meteorological data, and we also use the big data analysis and mining, and we have established the risk prediction models for DON during the harvest period for the wheat, as well as the growing stage of the wheat. And so we can have a dynamic data collection for the DON contaminations in wheat. And then we can provide support for the relevant policies making. And we have established the real prediction, and we have achieved very good results in terms of the prediction. Here it is a prediction model building. We studied on the different factors, for example, the climate, the agriculture, as well as the geography. And also we explore the factors that influence the generation of the DON in different production stages of wheat. For example, here we study about the flowering period, harvesting periods, temperature, air, humidity, rainfall, daylight, sunshine, and rotation. And also we study about the climate environment, meteorological conditions, as well as the farming factors regarding the occurrence of a DON. And here, this is about the early stage dynamic risk prediction system for DON contaminations in wheat. And we set up the prediction model. And we have get 3 invention patents from the country. And so after we get the patents, within 1 year, it has been authorized out. And so actually the technology and the demonstration areas covers the professional level, city level, grains quality inspection stations, as well as the third-party inspection institute, as well as the other national or local warehouse. And so the green part is where it has been applied. And based on the research and based on what we have experienced before, I would like to provide some suggestions. Number 1, to establish a unified monitoring and prediction system for the grain safety. And we need to set up a network and a system that cover the whole supply industrial chain. And it needs to be cross-department levels, and also share. We need to establish an information sharing platform. And and we need to make sure that the monitoring and the prediction of the grain safety needs to be unified and provide efficient services for the enterprises and the government, and the information needs to be shared and traceable. Secondly, we suggest that we need to further improve the grain safety and quality management mechanism and set up a mechanism for monitoring, prediction, and alarming, and also establish a mechanism or standards for the dividing and storage of the grains to improve the economic effectiveness of the enterprises to ensure that they can maximize their profit and utilize the grains at its best. Thirdly, we need to enhance collaboration in technology, including home and abroad. For example, set up the service system and set up the network regarding the grain quality and safety network, and also establish a library that includes the risk factors and as well as prediction models, and also establish the regulations regarding the management of the risks of the quality and safety of the grains. So this is my presentation. I welcome your criticizes. Thank you very much. Thank you very much, Mr. Wang Songxue. And it shares with us about the management of the grain contamination, and is a really comprehensive introduction of what we are doing regarding that. And also we know from the government level, how can we manage the grain mycotoxin contamination. And the next one is from the China National Feed Quality Inspection and Testing Center, Deputy Director Fan Xia. And she is going to share with us the research on mycotoxin contamination control technology. Welcome. Please wait for a while, and we need to contact with her. Due to the connection, the presentation of Fan Xia will be postponed. Next, I would like to invite Wang Liang from RoboLabs China, the technical manager, and he is going to share with us the application of ISO 17034 reference material and rapid detection technology in mycotoxin analysis. Welcome. Thank you very much. I would like to start my presentation. Good afternoon. And it's my great pleasure that I have this opportunity to share with you about the detection of mycotoxin. I'm from Roma, and I'm responsible for the technology support and services of Roma Labs in China. And maybe you know something about Roma Lab, especially in the mycotoxin detection. Actually, in 1982, we started the detection of mycotoxin. And in the work of the detection of mycotoxin, we always discussing with our team members that what's the direction of the detection of mycotoxin. And according to my own understanding, I will continue. Sorry, the connection is still not very stable. Or maybe Madam Fan, Maybe you first, all right? Dr. Wang, you start first, all right? I will make some changes of my system, so I will continue. And so for mycotoxin development, there are two directions. One is that it is the mass scale devices, and to actually it helps us to have the mass detection and make it even more simple. And for the technology of a detection, it needs to be suitable for the fast detection on site. It will overcome any bad situations and conditions, and to help us with the prevention and control of the mycotoxins. So I will focus on these two directions and to share with you some of the information about the detection of mycotoxins. And so actually here, my topic is the research on early warning technology. My research is about and my topic is about application of ISO 17034, reference materials and rapid detection technology. There are 4 parts. One is about the characteristics of the mycotoxin contamination. And then I will focus on ISO 17034 and the fast detection technologies. And also I would like to focus on some of the popular topics, that is targeted and non-targeted screening in mycotoxin detection. And so first of all, as Roma Labs, and we have a survey around the globe about a mycotoxin. And maybe you have seen this report before. And so starting from this year, and the DSM will help us with the publication of the surveys. And so actually the DSM is our new parent company. And all of the data, all the result, and is actually done in our lab. Well, China, as mentioned by Mr. Zhang Dawei, Wuxi lab is doing the report in China. And how we make the report? First of all, we have the data of the mycotoxin contamination. There is a positive threshold, and then if it is above that, and so actually, we also have a kind of percentage conversions of the values, and then we are going to know about the distribution of the mycotoxins, about the overall situation of the mycotoxin contamination.
From this map, we understand that the risk distribution over the world is different, and each region has different varieties of mycotoxins. As we can see, China in 2021, the number one mycotoxin was vomitoxin. Last year, fumonisin was number one, but it was later overtaken by vomitoxin. But still, fumonisin remains a very prevalent mycotoxin in China. And we look at the report in China and also APAC. Just sharing the positive rate is not enough to show the risk. So another thing that we did was getting an average value of all positive samples. If we use a percentage to show the prevalence of the contamination, then the average value shows the depth of the contamination, and the two values will help us understand better the contamination status quo. In the report, another fact was found. Multi-mycotoxin contamination was quite common, or co-contamination. 14% of the samples were free from contamination. 23% were contaminated with 1 mycotoxins. 64% of the samples were contaminated with more than 1 mycotoxins. So that was this co-contamination. And the hazards also have a co-reactivity. When we look at aflatoxin alone, maybe it is within the safety range, but with co-reactions from other mycotoxins, still the sample could be dangerous for human and animals. So contamination by mycotoxins, particularly co-contamination, is quite common. And based on the facts that we've observed, we've come up with the characteristics of mycotoxin contamination. It's quite common, and it contaminates basically all varieties of crops in the fields. And number two, the contamination could differ across regions. Different regions have different varieties of mycotoxins. So the prevention and control of mycotoxin contamination should be region-specific. And also, for a same sample, it could be co-contaminated with multiple mycotoxins. So based on the above, the testing for mycotoxins should satisfy certain requirements. It should be efficient, widely applicable, accurate. And on the other hand, we want the testing methods to respond to multiple mycotoxins because co-contamination is quite common. So based on the two, we believe that testing for mycotoxins should satisfy the requirements. So what are the technologies available? This is from US FDA. This is a simple overview of testing methodologies. On the y-axis, we see the convenience of testing methodologies, and the x-axis is the capability of data processing, the sensitivity, specificity, and data analysis. So this PLC, ELISA, HPLC, our capabilities grow with a liquid phase. Well, with LC, it is easier, more convenient, and in the future, what more methods will we have? We believe that in the future, we'll have a fully automated solution. And with LC, we could test for multiple mycotoxins. Of all the methods, PLC, ELISA, normally we test for one variety of mycotoxins. If it's prepared, we could test for multiple mycotoxins. And that is the future trend to go. So that is an overview of the technologies for mycotoxin testings. Moving on into the second part, the ISO 17034 RM. What is the significance of the RM? As testing methods evolve, as the accuracy improves, ultimately, the RM, or the standard accuracy, is very important. As you can see here, the standards can convert our test results to SI units to make sure of the accuracy. So the standards, or the RM, is very important to the accuracy of the test. So what is the comparison tiers? At the bottom, that is the single test results at the lab. And it requires a standard within the lab. And it should be calibrated with a CRM manufactured by a national organization. And ultimately, we can trace to the SI units. So the development history of the RM for mycotoxin testing, it is a privilege to share on the brand BioPure. BioPure is now a very famous brand for RM under Romer Labs. Before BioPure, there was no commercialized liquid RM. Our boss, Urban, and Tuan, Professor Ludi's department, worked together to manufacture this RM for us to have a quantized testing. And in year 2009, we registered this commercial brand, BioPure. The initial batch included RM for 90 mycotoxins. And in 2011, because of the 13 carbon marker RM, we received an award. So over the recent decade, Romer has developed our RM. In 2015, we launched our ISO Guide 34 RM, which is the preliminary form of the ISO 17034 RM. So this is certified by ISO. Later, we're going to talk about the ISO 17034 standard. It is more accurate and more credible for test needs. So far, Romer has about 150 mycotoxins with liquid and solid phase standards. This is the largest standard library for mycotoxin throughout the world. Now, talking about the ISO 17034 RM, what is it? It is a accreditation for the capability of the RM manufacturers. It requires how you manufacture the RM, and the standards is a generic quality assurance procedure, and it measures the capability of the RM suppliers. It's like ISO 9001. It's a manifestation of capabilities. It describes and stipulates the complete manufacturing process. So what data supports are needed? Personnel, environment, documentation, equipment, quality control, pursuant to ISO 17025, and the characterization of your backup ingredients, and the scope of uncertainties in the reference values. So ISO 17034 became effective in 2016, replacing ISO Guide 34. A guide is a suggestion, but ISO 17034 is the set of standards, so there's a huge difference in between. So for labs, do we need an ISO 17034 standards? So it is not required that ISO 17025 labs use ISO 17034 standards. But ISO 17034 standards used in the labs will make it easier for you to pass the accreditation towards becoming an ISO 17025 lab. It is stated here specifically that if the lab is using ISO 17034 standard, you are believed to be competent. So the ISO 17034 standards is a very important guarantee for the lab in passing the 17025 accreditation. So what is the correlation between the two? We have the demands for the standards. There's the measurement traceability, stability, and calculation of the uncertainties. And for ISO 17034, it offers a traceability, so you don't have to establish your own traceability description. And the standard method is deemed valid because the methodology that you employ is deemed valid and credible. And the homogeneity, stability, and uncertainty, it doesn't require spontaneous statement. That is why we say that the ISO 17034 RM, although there is not a necessity for an 17025 lab, it gives you a lot of support and additional benefits. So the ISO 17034 RMs, how is differently from other certified RMs? We know that it has stricter standards in terms of manufacturing. There are also differences. The RM with these ingredients, if it's 17034, you have to use QNMR to make sure of the purity of the ingredients, while generic RMs do not need to go through the QNMR method. Secondly, 17034 RMs have a complete COA accreditation report. For generic ones, it's not as complete. And for the ISO 17034 RMs, it is subject to short-term and long-term stability assessment based on ISO Guide 35, and also the homogeneity. Normally, we will believe that a liquid RM is already homogeneous, but even for liquid RMs with 17034, it is subject to a homogeneity assessment. And also for ISO 17034 RMs, there should be a complete report regarding the processing and validation and traceability, and also the manufacturers should be nationally accredited. So that is how the ISO 17034 RMs are different from the generic ones. The manufacturing and performance are all different. So Roma Labs, what are the products available from Roma Labs? For Flaxin, Vomitoxin, and the ZON, there is the whole product library, and it is still growing, which complies with ISO 17034. You might have the question, when we talk of RM, ISO 17034 is a capability accreditation. And when we talk about RM, we hear about RM and CRM. RM is reference materials, CRM is certified reference materials. So what is the relation between ISO 17034 and RM and CRM? It is two different dimensions in evaluating the competency of standards. ISO 17034 speaks for the manufacturing capabilities of the reference material, while CRM is a national accreditation for the reference material because it is certified. So two different dimensions in measuring the quality of the standards. So in the most ideal case possible, we want the ISO 17034 accreditation and also CRM, but some of the standards, it's not, it's RM, not CRM, because the manufacturing is subject to ISO 17034. But certain materials or the traceability of the raw materials cannot be guaranteed because the procurement of the raw materials, it does not have a complete traceability report. And there are some inherent insufficiencies, which makes it impossible to trace the raw materials. So this is an RM, but it is still a ISO 17034 RM.
And for ISO 17034 RM, and we compared it with the RM and the CRM. So what's the difference between the RM and the CRM? And you can see here in terms of the metrological traceability, there are different. And for RM, it's not required. And this, for example, we said before, and for CRM, it is required. And another hand, in terms of the assignment of the uncertainties of the property values. And for CRM, it has a requirement. It is required for certified values, but for RM, is not required. Actually, so for the RM and for CRM, this is the main differences. And so maybe you think that CRM, if you have a certificate, then it is CRM, it's not that. And we actually all can have a certificate. Actually, there are major two differences as presented, as mentioned before, between these two. And for ISO reference materials, how can we understand about it? And for ISO 17034 certificate, and for certificate, and we can see here what kind of information it is included. It has a traceability and the uncertainty statement, as well as the manufacturing process statement, as well as the characteristics of the product's description. And so actually in the certificate, they need to present all the information. On the other hand, besides that, we also need, according to ISO 17034, there needs to be certified, and the certificate is granted by the government. And in Austria, there is Austria Institute to present that. In China, there is authority that presents this certificate. With the certificate, you can manufacture the ISO 17034 reference materials. And so if you get a certificate, everything you manufactured is the ISO 17034 RM, not that. And also we have, for example, here you also need to include all the information here. This is the 6 pieces of information that we need to get. And here, this is one example of the certificate. And first of all, we have ISO 17034 introduction, and this describes what kind of standard that we follow. And also it has a statement of uncertainty and also includes the tests that we need to have. And we have a characteristic of the product. And we have, for example, certified value, stated uncertainty, homogeneity test, as well as a stability test. And also we need to show that the manufacturer has the capability to manufacture it following ISO 17034, and it can really meet the demands. And we also make a summary of ISO 17034 advantages and the product's application advantages. It's a certificate from a national level authority. It means that a national level authority confirm that you have this ability. And also for ISO 17034 RMP, if it is used in the ISO 17025 certified lab, actually it is confirmed that it is eligible, is qualified, and also it has the traceability and the authenticity. And so here it is the advantages of the products. After that, this is the second part of the presentation. It's about the fast detection technology development of mycotoxin. Actually, it's not a new topic. I want to discuss one topic with you. Talking about the fast detection technology, we need to talk about a scenario. We focus on accuracy of the detection, also need to comply with the regulations. When you use the technology, and actually, of course, you need to comply with the arbitration regulations, but sometimes it doesn't meet the demands of the enterprises. For example, we have limited area sometimes, and the time is limited, and the detection conditions are not quite very good. And sometimes it's difficult to use some of the technologies. And the fast detection technologies are sometimes, some of them are used in those scenarios. And so we have high efficient and applicable detection methods, and also it can meet the demands of the detection of multiple mycotoxins. And here, this is the strip detection, and we also have ELISA kit. And we realize the mycotoxin detection by these 2 methods. And besides strip and besides ELISA, do we have any other methods? And for us, we also use water as a base for the detection of mycotoxin. And I want to explain in details because actually Louise has already given you a comprehensive introduction of this product. And the advantages of these products are as follows. And here it is a strip fast analysis. It won't use the reference material. It's very convenient and it's very fast. It is a strip, and also it can meet the demands of a quantitative analysis. And also it's water-based extraction solution. Of course, not just water. We also have a buffer solution. And so this is for the safe consideration. It's safe for human beings as well as the environment. For example, in a chemical area, if you use chemicals, then it is not quite safe. And if you use water-based extraction solutions, and it is safer for that. And also for the same extraction solution, it can be used for different detections of different mycotoxins. It's quite convenient. And so actually in the front process, it involves a lot of work. And for example, for aflatoxin and as well as DON. For this method, we just unify all the kind of solutions, and we use the same extraction buffer for the detection of different mycotoxins. This is one advantage of it. And in the future, what are the directions of the faster direction? For example, the mycotoxin detection is one direction. And so we think that in the future, it will help with the on-site inspection of the mycotoxins. So this is the product. And this is the samples that we can detect by the AgroStrip vortex. And it is majorly used in the feed and grains. And so, for example, raw materials and grains. And we are also trying to enrich this table. And here in feed. And so we listed here, and it can detect the aflatoxin, DON, fumacillin, and the other three. So actually, for mycotoxin, for the risk management control, we cannot only use one single step to manage the risk of it. Actually, for example, we need to control the raw materials and also control the manufacturing step. And also, we need to make sure that in all the process, we control the risk. And actually, our methods, our technologies can be used for these scenarios. I can't change the slide.
All
right. So actually, we work with different enterprises. And for example, we still need large-scale devices for the detection, but for some of the enterprises, they didn't have such devices. And so during the detection mycotoxin, they feel that they are lack of the capabilities, and we offer a better solution. And so they can use a simple initial screening of the mycotoxin on site. And we also have a commercial lab in Wuxi, and then you can have arbitration detection in the Wuxi lab. And so, for example, when you come across any difficulties, you can first of all have an initial detection of the mycotoxins on site and to control and manage the risk. And so this is one very efficient way. So actually, I also want to share with you about LC-MS, this targeted and non-targeted screening. And for the targeted screening, you can consider it that for the known toxins, we have reference materials, and then you can compare it with the reference materials, and then you can quantify it. As mentioned by Zhang Dawei, and for example, we use the reference materials and we know the toxins, and then we can compare it to detect the toxin, the mycotoxins. And for non-targeted screening and for unknown toxins, and especially for the toxic metabolites, and we do not have reference materials, then you need the analysis from the data bank and to help us to detect it. And also we have a high throughput screening, for example, 600 high throughput screening. It is based on the non-targeted screening. And especially for the high mycotoxin metabolites research, they use the non-target screening. And for the screening, it is based on LC-MS, and it's the most advanced multi-poly mycotoxin analysis technologies. And here, this is 50 plus mycotoxin detection. It includes the known reference materials mycotoxin detection. It also covers the emerging mycotoxins detection. And we have heard of it, but we didn't know much about it. And it also will generate a risk. So we have the detection methods for that as well. And also we work with Buku. This is a Spectrum 380 projects. We have actually done the research and the analysis of almost 400 of the mycotoxins. And among the 10 samples, 9.8 out of 10 samples are contaminated with fusarium toxins. And that really support our research. And the DSM published the report regarding that. If you have any interest, you can contact with us for the report. In this way, we can have a deep understanding of the mycotoxin contamination. And here, this mycotoxins and metabolites research. This is my sharing. Thank you very much for your attention. Thank you. All right, thank you very much. And then next, for Madam Fan, are you still there online? I would like to invite Madam Fan to start. Can you hear me? Yes. So now it's your turn. The floor is yours. Can I share my screen? Can you see my screen? Yes. All right. So I would like to start. I really appreciate the invitation of Roma to share with you about what we have done in the research on early warning technology of mycotoxin risks and its application in pet food. And for the control technology, first of all, I would like to have a brief introduction of my institute. And for your understanding, for our institute, we focus on the agriculture products as well as feed, and to research on the detection methods, and also for the formulating of the standards and research on that. And also we take on the project from the government for the monitoring of the quality of the feed as well as the agriculture products. And we work with the government to have the sampling as well as grant them the technical support. And also the National Feed Quality Inspection Center is a division under the institute. And it is authorized by the National Ministry of Agriculture and Rural Areas and the Ministry of Agriculture. We are accredited with the license of National Agriculture Testing Baseline Lab. Well, the previous presenters have talked a lot about relevant work that we do as well. Shall I turn on my camera? Yes, please. If possible, we'd like to see your face. I think without turning on the camera, I give you more space for my slides. So this is a lot like the EU's reference lab. We call it a baseline lab. Or reference lab. And we have development of technologies, assessment, and standardization, as well as arbitration testing. And our testing technologies and control technologies for mycotoxins is also being developed based on research and studies conveyed on this platform. The content of my presentation includes 4 parts. First, an overview of mycotoxin. Previous speakers, as well as the EU experts, have already touched upon the topic, so I'll make these parts brief and succinct. So we harvest from the field the crops. The Cambridge professor already talked about that process, the harvesting and the processing, storage. Also, Professor Songxue talked about it, and Da Jing also talked about
the mycotoxin known grains and the assessment and testing, the sources of the fungus. Well, things are all related. So far, of the 30 varieties, 300 varieties of mycotoxins, there are mostly 4 types of modes. And there's aflatoxin B1, ochratoxin A, deoxynivalenol, T2 toxin, and ZA and FUM. These are the 6 most common types in animal feeds. On top of which, or in addition, there are new types of mycotoxins, and that way also talked about this topic. There are new varieties of mycotoxins, and for these new varieties, although some of them have not entered regulations, but we are seeing new valuations that are contaminations and reactivity. So they are also entering the scope of testing, despite they are not being monitored. Still, they're on the watch list. And there are the masked mycotoxins. And these are a type of mycotoxins combined with grain matrix component. And these mycotoxins are undetectable with conventional test methods, but once they're hydrolyzed, they might exert toxic effects. Here are some of the susceptible feeds and the toxicological information. The typical hazards to human and animals are found on this page, and we can find them from different publications and literatures. Because of mycotoxins, the #1 hazard is economic losses of the industry. For the food industry, in the world, about 25% of grain crops are contaminated by molds, and for animal feeds, this has been a global threat for livestock breeding and husbandry. The root cause of many problems are mycotoxins. So based on such backgrounds, the testing for mycotoxins and control is a very important area of study. First of all, the testing methods. This is tied to the hygienical standard for feeds, GB 13078. And we have developed several methods to test mycotoxins. The testing methods have their advantages, but when it comes to on-site testing, there are still limitations with timeliness in particular. So for mycotoxins, there are 2 areas of studies. One is rapid screening. The other is precise and quantized testing. Such methodologies, well, from previous studies, we've considered efficient extraction technologies and enrichment technologies. And there are risk assessment, toxin database, and detoxification agent mechanism studies. Now in the industries, there are kit and stripped being employed, and there are various products. The focus of our attention is not on development of such test product, because there are already many manufacturers working on it. We are more interested in the evaluation and assessment of the products and disclosing our findings to the society so that the feed industry can use such products more wisely. For example, the Roma Vortex product, which previous presenters already talked about. We evaluated their stripped and LCMS for aflatoxin, vomitoxin, fumonisin, and ZON. The conclusion is that the system is very helpful, and since we are currently undergoing the writing of our thesis, so we are going to officially share our findings later. For the purpose of today, I won't spend too much time talking about the data. In 2019 and this year, we've had 2 assessments of rapid test products. In 2019, we assessed 41 products from 33 manufacturers on the scale of 100. Ultimately, the Ministry of Agriculture issued an official circulation. We assessed the precision, sensitivity, and capability of the products, and the finding was officially released by Ministry of Agriculture with a list. In 2022, August, we conducted another assessment, and the findings are soon to be released via a circulation by Ministry of Agriculture. So which categories of products works better in application scenarios? We conducted a scientific assessment based on the work that we've done on rapid screening methodologies. We also conducted assessment, and we applied for 2 industrial standards. One is ELISA kit assessment standards for feed, and a fluorescent quantized strip. Later, we're going to share on the findings on the industrial-wide standards. As for precision and quantitation, we conducted our research based on the selection of devices, the methods of extractions and purification, etc. With the precision and quantitation, the selection of platforms will include LC and LCMS. JPLC for large feed manufacturers, they have a wide application. For LCMS, there's no problem with the testing labs, but for manufacturers, they prefer to use it for rapid screening instead of precision quantitation. And LC and MS are mostly used in testing facilities, and LC is more common. This applies to the hygienic standards of feeds. It's mostly based on LC methods, including GBT 30955 and all the way to 30957. These are all based on LC. The LC technologies, the separation analysis assays are quite effective. It can test for multiple compounds, high resolution, high precision. So far, in the hygienic standards for feeds, there's the agriculture industry standards. And such standards are already being applied and adopted. We mostly test for one indicator. For 2071, it tested for 3 indicators. And currently, we are conducting more surveys and research on QE and 6500. Our current methods can already test 11 mycotoxins. Dr. Wang from Romer and also Da Wei talked about their methods. They can already test 50 mycotoxins. So we have different application scopes. Based on QE, well, this can work in collaboration with the non-targeted method. This is based on 6500. This method, we noticed that in addition to the devices, there's the pre-processing efficiency benefit. On these 2 platforms, we are also focusing on the enrichment and purification technology. And there is the immunoaffinity column technology in 30955 standards. And the next one, it has recommended the immunoaffinity column technology. And we've developed this fully automated purification system leveraging immunoaffinity column, IAC. And in the future, we are going to publish our research findings when we share our data. This, to a great extent, can save us the manual labor of loading the samples and a lot of other procedures. And the immunomagnetic bead separation, we also have a research. Also, we compared it with the IAC, and we've applied for 3 group standards. This year in September, the project was approved, and currently we are preparing the standards.
If you have any interest in that, you can follow up on our work. And also we have the MUX-based materials. And we also have a PhD that doing the research work. And in the previous 1 year, we have done research on 9 MOFs materials. We have done related research. Well, for the report, actually, we have also submitted our report to the magazine, and very soon we are going to share our research result with you. And we have compared with different MOFs materials, and we have a PCA 94, which is really good, the absorbent materials, and it has a very good effect in purification. And so here, this is MOFs purification material optimization. And right now, we are also doing research on the compound of MOFs materials, and we have our in-house MOFs materials, and hope that later on we can share more information regarding that. On the other hand, in terms of mycotoxin, we also focus on the research of emerging mycotoxin. For example, in pancreatic acid and TF. And we have done research regarding that. And we actually studied on the fermentation products in the feed industry and do the research regarding pancreatic acid and TF. And also we have another research regarding the detection method, and we have already published the related research on magazines. And so on the other hand, in terms of the detection methods research, based on the detection methods, we also established a screening platform. And it actually, on this platform, we also focus on the mixed mycotoxins and mycotoxins. And also we put the information regarding the reference materials on this platform as well. And this platform is also used for the unknowing mycotoxin research. And so with that, and as well as the other research that we have done before, we can actually realize a non-targeting screening result. We can develop the non-targeted screening technologies. And we have published the notice actually through the Ministry of Agriculture. We already established a library of the toxic data, and we extend the library. And also it includes the veterinary drugs as well as pesticides. And based on the platform as well as the detection method, we also have started the research of the risk evaluation regarding the mycotoxins. Well, actually, Da Jing mentioned about the risk evaluation in the food industry. Actually, this is the same thing with that. And for the feed industry, it has a very short, comparatively shorter industrial chain. And we also have the risk evaluation research as well for risk control. And also our research focuses on the susceptibility as well as the co-contamination. And then we can submit the alarming information. So here, we are collecting samples, and also we are expanding the coverage of the screening. Yet previously, we have introduced to you about the detection method and how about the collection of the mycotoxin information. And we also have done the detoxification and the related products effectiveness evaluation. And for example, for the physical detoxification, chemical detoxification, and biodetoxification, we have done the research regarding that. And also we have in vitro methods, and here this is the enzyme degradation methods. And well, in the market, there are many methods to use enzyme to degrade the toxic, and there are many reports and news regarding that. However, we only have one product that has been approved by the government. That is a product that dealt with the aflatoxin, and it has been used. But actually, as far as I know, it doesn't have a lot of applications. And for this new products, one before it is used in the market, our center was responsible for the evaluation of the effectiveness of the product. And the year before last year, actually it was early of last year, we evaluate another products, and it is a physical absorbent materials, and to deal with the toxin, to absorb the toxin for degradation of the toxic. And our center was also responsible for the evaluation of the effectiveness of that products. And we have in vitro methods. And there are two platforms for that. One is conventional solution in vitro method. And for example, and here we listed the information. And also another method is a nutrient-based solution for microorganisms. and to calculate the degradation capabilities of the products. And also for the in vitro methods, there's one thing to pay attention to. For different feed, well, they have different mycotoxins, and we also need to study about their toxicity. And right now, we didn't have a sufficient data and for that. For example, we need to ask the question that different feeds produce enzymes or fungi and different influences, and we also need to have a specific analysis of specific cases, and also we need to have research on the toxicity of degradation products, and also we need to consider, is there a reversible reaction? And also we have done animal tests for the in vitro methods, and to evaluate the effectiveness of the products. And here, this is a long, more absorption model. And based on that, in September of this year, and we apply for the projects, and one is about evaluation of the toxicity of the absorption in vitro methods, and we apply for 2 projects regarding these, and hope that if we can set up the project and then share the information, we can have more communication with the industry. Besides that, based on the research that we have introduced to you, and we also focus on the research on the pet food, because pet food is quite a popular topic in the market. And so at pet food, we also have the feed that can pet feed. But actually, the mechanism is different, and sometimes the detection method will be different from the mycotoxin detection methods. And in regulation, it is specified that pet feed actually refers to products that are industrially processed and made for pets to eat. And in recent years, we have some cases regarding the toxic events of pet food. For example, here in 2022, we also have the cat food events. And up to now, we also have ongoing cases that is related to mycotoxin. And according to the regulation of mycotoxin, and we focus on 6 of mycotoxin, and HT2 and T2 toxin. And so the method is different from the 2071 regulation. Actually, we adopted another different regulation. Why it is different? And because for this method, and if we want to detect T2 toxin and HT2 toxin, if you use a conventional feed detection methods, well, it is not applicable. And so when we're making the regulations and we select a more applicable method, and for the mycotoxin detection in the pet food, and so here we have thin layer chromatography methods, but it is not widely used. In pet food manufacturers, actually, they use immuno methods, for example, colloidal immunity methods, and as well as fluorescence immunochromatography methods. And for the food manufacturers, what they care is more than that. And in terms of the detection methods, and they have higher requirements for the detection methods. So right now, many of the feed manufacturers, they need more detection methods. For example, the high efficient LC methods or LCM SMS methods. T2 and HT2, they use the export and import regulations, and there are still some problems regarding the detection of T2 and HT2 toxins. And in the early of this year, and we also apply for the setting up of the projects, and we submit to the Ministry of Agriculture. And also, it is based on our 2 to 3 years of research on the conventional methods. And then we identify some of the problems regarding the conventional methods. And that's why we suggest that we need to set up a project to do the research. And we also propose another project to set up the projects to do the research as well. Well, it's all based on our research. On the other hand, in terms of the food, our previous work also considered about the real application. And for example, we research on the reference material verification, as well as the pet food pre-processing methods. And we have gave a lot of suggestions and hope that in our future work, we can also give you a suggestive instructions. Then you can avoid the same mistakes, or you can actually follow the standard methods. And also for the verification of the positive samples, this is where we also need to pay attention to. And for this year, from April to August, and for the pet food quality, we have done evaluation work regarding that. And for example, we get samples from the enterprises as well as the online shopping mall, and we have done research on the evaluation of the products. And so actually, for our sample, among the samples, it meets the basic requirements. And later on, we also submit the report to the Ministry of Agriculture, and the Ministry of Agriculture will publish the report and the related information. So this is the sharing from me about the detection method and the technologies, as well as the application in the feed industry, and something about the pet food. And I welcome your communication and exchange.
Thank you, Ms. Fan. And we have a Q&A session, actually. Please bear with us.
您看一下网上有没有问题？有问题吗？好的，对，那我们就不上台了吧，反正啊，对对对。然后
There's no need for the panelists to go on stage. I see a question about pet food. Actually, shall I answer directly? Or maybe you can read the question first before answering it. For pet feed, testing methods for mycotoxins are mostly of standard methods for feed. Are they verified and validated for pet feed? When we made the hygienic standards for pet feed, they have been validated. But circulation number 20 came out really fast, so there was verification, but not enough. So in the future, there will be monitoring and also authorized tests, as well as our spontaneous testing for food safety of pet feed. And as we conduct such tests, certain issues were identified. And there were some key steps being problematic. So in the future, for each pet feed, we are undergoing establishment and development of more suitable methods. Okay, thank you, Ms. Fan. One question for Mr. Wang Liang. The AgriVision test methods, does it have certain requirements for water? Can we use tap water or do we have to use purified water? When we extract samples, we better use distilled water or purified water. The easiest method is to use bottled water such as Sebon or Wahaha, because the tap water might contain chlorine or ions. So for commercial labs or professional labs, it is recommended that we use distilled water or purified water. Professor Da Jing, are you still with us? Mr. Zhang from Mars.
I have just one question regarding the decontamination, and Professor Fan, and just now you just mentioned that there's only one product that has been approved, but by the Ministry of Agriculture in China. So, can you comment on how widely this is used so far, and do you see this being widely adapted and adopted really by the industry?
Is Ms. Fan still with us? I wonder if you got my question in Chinese. I'll say it again. Only one agricultural product was approved by the Ministry of Agriculture with the degradation of aflatoxin. In your presentation, you said that the scope of application is quite limited. What is the problem? And is it possible for us to further expand its scope of application? Dr. Zhang, hello. The Ministry of Agriculture and Rural Areas approved this one, or let's say this is the only application filed by the manufacturer that has been approved by the ministry. But in the market, there are a lot of enzyme products are being used. It's just that they are under other categories. Some of the products in their label and marketing. For example, Bacillus subtilis, it says that it can degrade toxins, and it is also based on the enzyme mechanism. Jinan University, it was a product by Jinan University, so probably they did not have such a big budget in marketing as other manufacturers. Okay, thank you, Ms. Fan. I think it's time for us to say goodbye, unfortunately.
So thank you so much for your staying with us. And if we have any questions online, we will ask questions in the Zoom. So thank you. 也谢谢现场的观众。
Thank you to our audience in the room as well.
安主任，谢谢啊。
Thank you, Ms. Fan. You're welcome. Goodbye.